where in geometry and in vectors, we focus on which piece, a direction or a magnitude?
Direction.
Magnitude.
I don't remember. You don't remember.
Both.
Wait,
Both.
ask the question again, please.
Well, you were not in my geometry class when we did vectors.
I can
Okay.
time travel.
So,
I feel segregated in the past. Just because I was a kid.
okay.
I cannot.
Yeah, there's three of you. It's okay. Yes. Magnitude. What does magnitude mean?
The number. It has the degrees of it.
Yeah, that sounds good. I think it has something to do with degrees.
I thought we talked about
The
quantity.
quantity.
North something.
I'm super lost because I totally thought it was direction.
I think that's
It
it was not.
quantity.
Quantity. What do you mean quantity?
Number. Like quantity.
Okay.
I can draw a vector and show you what.
Okay.
magnitude.
So if I draw a vector,
Yes.
what is that vector's magnitude?
Do you have a ruler?
Do you have a ruler? What are you gonna measure?
That line.
That line. The
The
what? The length. And if you keep talking, the length or the
Distance
The
formula.
distance formula.
Are you
So
thinking
when-
I remember that.
when you were in geometry, we were deep into the distance formula. The magnitude of a vector is its length or its distance.
Is this
It's like D
7.4?
equals the
It
square
is.
root of x1 minus x2 plus. Is that it? Or is it plus y1 minus y2 squared? Yeah.
Yeah, that's the distance formula. Okay? So do we have to have 2 points for that?
Yes.
Yes.
Cool.
But there's just a vector out there. It's an arrow. I heard a ray. Okay? There's an initial point
Origin.
where it starts. Every initial point we're gonna put at the origin. No matter where it is, I'm gonna put that at 0, 0. Okay? So if I have an X and a Y that are both 0, 0,
And that's pretty easy math.
that distance formula becomes very easy, right?
Yes.
So if I put a 0, 0, that literally becomes what? X.
X
Squared
plus y squared.
Does that look familiar? What happens if I square both sides?
D squared
It's the
equals X.
Pythagorean theorem.
It is the Pythagorean theorem.
Oh yes.
Okay? So if you have components, do you remember what are components of a vector? We have the magnitude. Now the components are at the terminal. What is the terminal point? Where it ends. Where it ends. And we would literally give it an x, y. So if we go over 1, 2, 3, 4, 5, 6, 7. Up, how many am I going to go up? 1, 2, 3, 4. The components are in the form of an x and a y, but they have these, I call them the sideways peace signs. Because that's me. Or it's a greater than, less than. I mean, all I can think of is doing this. Okay? The components are your x, y, where you're going to. We can name a vector. Do you remember how we can name a vector?
Yes.
Call it Carl.
Carl.
And now it has a name.
Carl. Put a C.
Oh no.
Oh, yeah.
And it's got kind of a half ray on top. It kind of is like a ray,
Meet
but it only has a top on one, like the shark fin.
Carl.
Keep going back. Go back to the sharks. So, if we wanted to find the magnitude, I'm going with this of vector C. This is how we are going to see the magnitude. The magnitude of vector C is going to be in those like absolute value symbols. That's not what it means. It doesn't mean absolute value. It means what is the magnitude.
C.
Magnitude of vector C. So we're going to plug in. It's going to equal the square root of x squared plus y squared. I have the components of 7 and 4.
Wait, what is that?
What is what? This?
Yes.
That says initial point. I put a dot when I
Oh,
put it there. But then I've gone lines through it. Sorry.
Okay.
Where we started, where we end. So 7 squared is 49 plus 16. 65. So the magnitude of vector C square root of 65. I don't think that will break down. Pretty sure it won't. Okay. Yes, ma'am.
So if you have a vector that goes into like a negative,
Okay. Do we want to do that one? We're going to get to it very soon.
I should just go for it.
Okay. Are we okay with this? Finding the magnitude.
3 seconds. Thank you.
So I'm,
7.4.
this is 7.4. There we go. There's a vector. This is the arrow end. This is the dot end. This is vector V. And they usually do like an italicized, so that's why mine was a little weird. So if I ask you to find, I'm not going to say it, I'm just going to do this. Actually, before I ask that question, I'm going to take that question away for just a moment. What are the components of vector V? Then,
Don't we need to know what is the initial point and terminal point?
that's why I put an arrow here and a dot there.
I mean, what's the component of initial point?
Everywhere you see a vector, vectors are just out there. Every initial point, where are we going to put it on our coordinate plane? We're going to put it at 0, 0. Every time, no matter what. I am not ever going to draw a coordinate plane. I put squares up there, so it will be easier.
Okay.
Okay? But you are doing your own. I'm going to do it this time. Coordinate plane. So we are starting every initial point at 0, 0.
How do you pick which point is the initial point?
Because I put a dot there. The arrow is the one going at the terminal where it ends.
Gotcha.
So what are the components? Taylor, what are the components of vector V?
6, 5.
Is it a positive or do we go backwards? Can it be negative?
Yes.
Yes, because we went left, so I would say it's negative 6. And we went down, so it's negative 5.
What would you call that besides this? Just curious. I didn't know if it was like a certain practice.
So magnitude.
So what is the magnitude? Where do you plug it in?
Square root of 6 squared plus 5.
Does it matter that the x is negative 6?
No.
Does it matter that the 5 is negative 5?
No, you will square it.
Because when you square it, it becomes positive. That's 36 plus 25.
61. Square root of 61.
Can your distance, can your magnitude ever be negative?
No.
No. Why not?
Because it's a negative, then you're square it.
You can't have a negative force.
You can't have a negative distance. You can't have a negative, did you say force? Physics. So, yeah.
In physics, negative distance means south. Go back.
Which direction you're going?
Yeah, direction.
Alright.
That's doctor.
They give a lot of things. And do you remember the words opposite vector?
No.
Well, I do know the words opposite and vector,
Does it mean like
but when you put them together,
do you like
not really sure what.
Is
they
it
mean.
like
Is it
upside down?
opposite?
Deflect it?
So,
Is that y equals x?
Do you flip the signs?
do we just flip the signs?
That sounds
Yeah.
easy. Wait, what?
That definitely sounds easy.
Yeah.
So,
Oh, jinkies.
oh wait.
Oh, that was.
Oofers, man.
Oh, you just swapped the x and the y.
Oh.
Are those opposite vectors?
Yeah.
No.
Wait, shouldn't
No.
you start it
Wait.
at 0 though?
No.
Every vector, the initial point
Yeah.
is at 0. So
Oh,
guess what I'm gonna do? I'm gonna draw another coordinate plane, 0, 0.
is
And it's going over 1, 2, 3, 4, 5, 6.
So you flip
And
the
it's
x
going-
and y and the signs?
what does that
Maybe
mean?
X and
Like,
Y.
it means
But it doesn't matter where I put this vector. This vector W has components that are what?
so it.
Oh,
Now it starts here, it ends here.
So does that mean the magnitude has to be the same but in different quadrants?
The magnitude is the exact same.
But different,
We don't care about the quadrants. We are putting the quadrants there.
different
They're
points.
really not there.
Different points
Sure.
and same magnitude.
Sure.
Oh.
They have to have the exact same magnitude. The x's and the y's will just be opposite of each other. So you're looking at negative 6. What's the opposite of negative 6?
Positive.
Positive 6. What's the opposite of negative 5? Positive 5. Could I pick this vector up? Oh, no. Pick that. Oh, what in the world did I just do? Okay.
Oh.
It's mad.
Active is for quit unexpectedly. Reopen to read an application. And this is it. We'll take this.
Active inspired.
Active inspired.
Does that happen a
You're
lot?
No.
hilarious.
It doesn't happen that often.
Oh, that's.
You probably don't want this.
No, it's Trig.
There we go. There. And then we were on this page.
Next.
There we go. I will not try to move that again, but could I put that same vector with the same initial point and go in this? Oh, sorry if you're watching.
Oh, jinkies.
Sorry.
Wouldn't that just be a line?
Would it? Okay, 1, 2, 3, 4, 5, 6. I'm gonna have to go right there. That is an opposite vector. Okay? They can have the same initial point. They could be directly on top of each other, just going the opposite direction.
Or it could be like
So
over
you
there.
just draw.
It could be over there, it could be anywhere we want it to be.
So you just put two opposite vectors. So which one do you
Hey.
want?
Well, if I have a vector and I said give me its opposite vector, you're just going to tell me the components of it.
Oh, what can I draw?
You don't have to draw it, or if it says to draw it, I don't think any of them do.
Okay.
Then you can put it anywhere you want.
Why did you shift it down?
Why did I shift what down? This? That was a mistake. This was when I was moving things, and this is not supposed to be there.
So
This vector is still a 6, 5 vector.
So it doesn't have to be attached to that.
Mm.
Oh, okay.
but why is it called
It can be
opposite?
wherever
It's not
your
opposite.
little heart desires it to be.
Yes, it is. It's going the opposite direction
Like
with the exact same
the
magnitude.
W.
Yes, it is. Vector V, it starts, it's going left and down.
Oh, left down. Opposite.
So W is going right and up. So in the opposite direction.
Okay.
It will have the opposite components, but it will have the same magnitude.
Okay.
Do you happen to remember that we can add vectors?
Add that.
If you add vectors, you get a resultant. SU.
I feel like I'm in
Everything
chemistry,
back
like in
to the
physics.
It just depth.
Oh, okay.
A resultant vector is when you add two vectors. Okay? It's really not good for your eyes to do that.
And I have like doubles,
He has
so, like
contacts
contacts
in,
and
too.
those. Thing is, I can still see perfectly clear. It's just like depth and everything is weird.
Good catch.
Like
Yes,
you look
my
su-
favorite.
You look like
Okay.
super far away, but like now you look like
Normal.
it's
Okay.
wild.
So if we have a vector V that had it depends. Do you want to see this visually first?
Yes.
Let's go visual first. Because I like it visual first, and I don't know why. I think you wouldn't. Okay. We have a vector. We'll start out with a different vector. We'll be nice. Okay, that's good. And a vector over here. Okay? Everybody see the initial point of each one?
Yeah.
And let's give it names vector A and vector B.
Vector
Okay.
Adam and vector Brian.
Can you find the components of vector A?
Yes.
What did you get?
1, 2, 3, 4, 5. 5 and 3.
Vector B.
3 and 2.
3 and 2.
Yes.
Is that correct?
Yes. No.
But it's going
Not
up.
correct.
So
Not correct. We went
Then
over
2,
3. We went
Down.
down.
Down,
2.
down.
Going
Okay.
down.
A resultant,
Will
You
be
just add.
you simply just add them.
So 8, 1.
Visually, you can take the initial point and put it at the terminal point. Why won't it go on the exact line?
and the
How is
result.
that added?
Okay.
Oh.
So then, and then you just go from the first initial to the last terminal. Any of the
What is the result?
Okay.
Is
So
it
the
like
resultant vector
A to
is
B?
the first initial.
is, I'm still on that. Let's go to,
Go back.
okay, pen. Our resultant vector, why did I make the B red?
So we need to do x1 minus
Okay, this is the resultant vector. Vector A plus vector B. So what are the components of vector A plus B?
A.
Do you add the x's and the y's?
Well, you can do components. 1, 2, 3, 4, 5, 6, 7, 8. 1.
Oh, that works.
But you can't add them because it's the same.
5 plus 3 is 8. 3 plus negative 2 is 1. You can simply add the
Can
x's and add the y's.
Can you write it as vector AB?
No.
You
No, because that implies you multiply, and we are not multiplying the vectors yet.
Plus this.
We added them.
I
This is distance formula. I did not ask for the distance.
Oh.
I did not ask for the magnitude. Yes, ma'am.
So I was gonna ask how this has to tie in with like the lesson of triangles. Is it because we made a triangle?
We made a triangle. Okay. We did. And if I were to ask you, what is the angle, if you want to know how we're tying this back, what is the angle between the vector A and B?
Oh, jinkies.
Go. What?
Oh, I said, I got you.
Oh, is it second?
Find the angle
Yeah, but you gotta.
Oh my goodness, this is amazing.
between vectors A
Math is so fun.
and, that's an and,
Did you say fun?
B.
Why is that hard or fun?
Wait, but she because he left.
No, be quiet. You guys all have a problem to do.
Okay,
Multiple problems.
I will. I will. Hello. I'm sitting in the speed.
So what did you have to find? You had to find all of the magnitudes, the lengths of all the sides.
Wait, I think you already have them.
How?
Because the X value.
You have components. These are components. This is where it ends. If you need to find an angle, you really do have side, side, side.
So you start with the
Once you find all of the magnitudes, the lengths of every side.
So you don't have the links.
Do it.
You don't have the links? I'm just confused.
You can find them. You have the skills right at this moment to be able to find them. This is the square root of 5 squared plus 3 squared. You have the magnitude of B, which is the square root of 3 squared plus 2 squared. You have the magnitude of the resultant vector. Yes, what do we get? 8, 1. So 8 squared plus 1 squared.
Is the distance formula the plus in the middle or in between?
It's a plus in the middle because what we've done is we've subtracted 5. I've written the distance formula up here for you for all of these. You're like, wait, that doesn't look like the distance formula, but it does because it's 5 minus 0 squared plus 3 minus 0 squared. Right?
Yes.
Okay. So it really is just the Pythagorean theorem.
Math is crazy. Everything is just the Pythagorean theorem. All of it. Because this comes with the Pythagorean theorem. Doesn't the quadratic formula go back to everything?
Law of cosine.
Yeah, wild. So what I'm hearing is that the Pythagorean theorem is essentially just like college parties. Wild.
I was gonna say it was more like the Latin language. It's where everything else comes from.
I see. I was going with the wild. Ole Miss.
Yes.
Wait, so
Nine.
whatever answer you get, do you have to like put it in its simplest terms as you're just gonna plug it into another equation?
Because what are we fixing to do with all of these? Square them.
So it doesn't.
Leave them as square roots. Don't even try to simplify them. I don't think anything will.
65. And then
So now, which one are we finding first? It's actually the one I asked for.
the longest.
The longest. So we have, I really can't scroll down very much or I'm going to lose stuff. Can you find the angle between vectors A and vector B? We're tying this back to what we have already done. So we have the square root of 65 squared equals the square root of 34 squared plus the square root of 13 squared minus 2 times the square root of 34 times the square root of 13 times cosine whatever we want to make that be. I said B, but I put a C there. I have A and B and C. This, I mean, if that's my angle, it's my missing angle. Just because it's between sides A and B, it really just, you can make it any letter you want.
This is like a throwback to when we learned the distance theorem.
Yes.
Why is the x value not the distance? Like, I'm so confused as to why we have to find the
25 plus 9 is 30.
the magnitude.
Well, I don't know.
I mean,
You see what I'm saying? It's like for vector A, you got 5, 3. Why is that not just 5?
why is that length not 5? Because if I'm going 5 units, I'm here 1, 2, 3, 4, 5. That is 5 units. Okay? That is the magnitude of 5. Okay? When you go diagonal, is the distance from here to here 1 unit? Absolutely not.
Square root 2.
It is a square root of 2. How does he know that automatically? This is a 1. This is a 1. This is, I started saying 1.4 and I wrote a 4. It's a square root of 2, which is 1.4. So it's almost 1.5. Okay? So when you go diagonally across these boxes, that is no longer 5 units. I went over 5 and I went up 3. So I want to know how far is this. So we could have made a right triangle, had 5 here and a 3 here, and put our hypotenuse there. And it's the Pythagorean theorem. All right, can we go down here? Do math.
Yes.
What is the angle?
115.
I know, that's why I'm trying to hurry.
115.
So 65 equals 34 plus 13 minus 2 times all that cosine C. And what did you get?
115.
115.
That's the answer.
I don't know. I didn't do it. Would y'all like me to do it?
Yes, please. Well done.
I think me and Emily killed it and got it right.
Awesome.
Good job, Tyler.
Good job.
What was the answer?
I got 125.